All right. Hey, everyone. It's Aaron again. And I wanted to start off a series about building a Go app, a real Go app, and getting it up and hosted on Azure, and then actually hooking it up to a real website to solve a real problem. Um, Something I haven't really done before across all the screencasts that I do. And I thought this would be really fun for me to actually solve a real problem over a screencast. And I would hope it's useful as well to see, everything in action from start to finish to actually get a real app up and running on the real internet. So I'm going to apply this app to the Go study group. So the basic idea of the Go study group, you can read a lot more about it here, and I'll include a link in the show notes. But the basic idea here is that a bunch of folks get together, and those folks are all around the world, and they just kind of casually discuss some topics in Go. So there will be either some folks who want to talk about something new, talk about something maybe that they're working on, and share that knowledge. And then there will be other folks who want to come and learn about something. And so the way that we kind of organize that across all the study groups is that folks go in and they submit items to this thing we call an agenda. So we've got study groups that go on all the time, and generally for one region they'll happen once a week. And before the study group, that whole week before, folks will go in and say, hey, I want to talk about this thing. And other folks will go in and say, hey, I want to learn about that thing. And we keep it really informal because we kind of say and show that, you don't really need to be a public speaker or, prepare a talk or anything like that. You can just kind of go in and talk or listen. And this is my favorite part here that I highlight is you can come and lurk and learn about Go, and you can also come and chat about Go. And that's regardless of, your background or your experience or anything else like that. So anyway, we've got study groups right now for the US and those time zones, and then for India and those time zones. So now that we have two study groups, we've kind of got these two separate agendas and these two separate meeting times. And we're kind of getting to this point where it's confusing. We've got one agenda here for the North America one. And, this describes what the study group is and that everyone's welcome and the time and all that kind of stuff. And then, of course, there's the agenda. And if we go over here, this is the one for the India and similar time zones. And so this is a completely different format. This is obviously a GitHub repo, and it's got markdown files for like past sessions. And I'm actually not super familiar, which is obviously kind of shows off the problem here. This has like proposals and RFPs in it. And that's the format that they use, but it's totally different from the format that the US study group uses. So what I would like to do to kind of reduce some of the confusion across the community is to try to bring the two agendas together. And so folks can use different formats and so forth, but it would be nice to have the agendas on this page right here so that anyone can go to this landing page for the study group. And they can see what's coming up next week. And if they want to add something that either they want to talk about or they want to learn about, they can enter it here as well, and it'll go onto that agenda. Okay. So then the last piece that I want is I want people to be able to come in eventually and rearrange the agenda if they're sort of an admin. And maybe even one day have people come in and vote, have anyone be able to come in and vote on items in the agenda so that we can kind of keep this as maybe call it an unconference and have people talk about or learn about the things that are most popular. So not exactly sure about the sort of community aspect of the voting and everything else. But what's really important from now is I want to get some logic, some dynamic logic onto this page so that we can have those kind of new call it new, like processes and new features in place that the community can take advantage of. Okay. So this is a static page, and we want to keep it that way because this is a page that, it has nice graphics and everything, but it won't go down. It's managed and hosted by someone else, and we don't have to worry about keeping servers running and so on and so forth. So that's great, and we don't want to change that. But we do want to add some little pieces in here that are dynamic and can serve the community better, but still want to keep that kind of concept of not really having to manage servers. Okay, so we're going to be strictly adding to this page, not moving the page or changing technologies. We're just going to be adding content and adding new technologies. Okay, so in the end, what we're going to do is we're going to host this. We're going to obviously write some code, and then we're going to host that code onto Azure App Service. So let me do a little search for that. And we go to Azure App Service on Linux. And you can see here, basically, I think it's also called Azure Web Apps. And there's a lot of text in here, and you can talk about, you can go read about that. But the way that I like to sum it up is that this is a platform as a service. Okay, so we can go down here, you can read all about it, and there's instructions on how to get started. And I'll actually be following those instructions in a screencast down the line. But basically you can go in here, you can figure out how to get everything done. Since we're a Go study group, of course, we're going to be using Go. But we're going to be using Go in the Docker configuration for Azure App Service. Okay, so this is where the magic is going to happen. Because we're building Docker images and running Docker images, we can use any language at any version that we want. And that's important because we're going to be using Go 1.11. Okay, and we're going to use it in this very specific configuration. Okay. And our Go application is going to hook up to Cosmos DB to store the data with all the agendas and so forth. Okay, so we're going to be going through this stuff in a future screencast. But for now, I want to go through the code that we're going to be writing. Okay, and a little bit about how we're going to be building those Docker images. All right, so here's the code. I've built a super skeleton kind of repo and code base that we can build off of down the line. All right, so I'm going to open this same code up in VS Code, and I'm just going to do a really brief run through on what's already written, what I already built, so that we can have a foundation that we can build on top of. So let's start in our main. So I think everyone watching is a gopher or is familiar with Go in some way. And if you're not, this is kind of familiar in some other languages too. The main.go has a package called main, and the entry point to our entire program is the main function. All right, so we've done some stuff with configuration. I won't get into that just now, but basically we get back a configuration struct, and that has all the things like what port to run on and some of the MongoDB credentials for the database. And we're going to be using Cosmos DB's Mongo API, so we can use standard MongoDB libraries in Go to connect to it in production. All right, so down the line here, we're using this framework called Echo, and I'll show Echo in a second. And I'll also put that in the show notes. And so Echo is a great framework to build APIs, to build REST APIs specifically. Okay. And there are other frameworks out there. There's one called Buffalo, and I love Buffalo, but it's more oriented towards building front-end web applications or web applications that even can be APIs, but connect to relational databases like MySQL and PostgreSQL. Okay, so I don't want to do that today. I want to talk to MongoDB, and I also want to keep this fairly simple, and Echo kind of lets me do that. So we go down the line here. I have this struct that I'll look at in a second called items, and items just has two functions, items.list and items.add. And those two functions are echo route handlers. So I've got two routes. They both start with /API, and one is /API / a name of a Go study group. And that's a GET request. So that's going to list all of the agenda items for a specific Go study group. So if I make a little comment here, so if we have something like get /API /USA, that's going to return all of the agenda items for the US and similar time zones for that study group. Then if we go down here, we have a post /API /group name, and that is to add a new element to the agenda. So if you've got post /API /India, that's going to be adding a new item to the agenda for India. And the body, the HTTP body of that post request will have all the information about the item and probably the time of the study group that we want to add the item to, and down the line, so on and so forth. All right, so I'm going to go ahead and delete those comments that I just added. And then we go down here. This is basically just starting the web server. So there is the use of that configuration struct that we got way up here on line 12. So we're going to be starting it on a port that was specified in the config, and then we're just starting the server. And you notice here we're wrapping that e.start in a fatal log. And the fatal log just means that if the server crashes, we should have a fatal log so that our process exits with I think it'll exit with a non-zero code like 1, so that the Azure Web App, that's the Azure Web App runtime that's running this container, will know that it failed. And so what that means is e.start should run forever unless something fails. So that's an important bit. Okay. So if we head over to items.list, items.add is also in there, and they're both pretty much bare. These are obviously things I'm going to have to implement. Okay, so we'll get to implementing those in the next screencast, and then we'll get into how should we test this stuff and so on. Okay, so the last two pieces I want to show are how do we do dependencies to get things like the Mongo and the Echo framework. And then finally, how are we going to build this thing into a Docker image? Okay, so first, dependencies. We have this go.mod file, and the file has a bunch of requires in it. Okay, so this is the new Go 1.11 module system. So the Go 1.11 module system gives us this format in this file that we can tell it what dependencies we need, what packages we need to pull in order to build our program. So we need, of course, the Mongo driver, we need labstack echo, Viper is what we're using for configuration, and golang.org/x/text that is used by a couple of these packages sort of under the hood, but we want to fix that at 0.3, okay? If we look in go sum, this is like the lock file. This has everything, our entire dependency graph, including our transitive dependencies. So that's dependencies of our dependencies and dependencies of those dependencies and all the way down the line. Okay, so we've locked in everything we need. And when we run go build or go test or go run, it will automatically check to make sure that it has all of the right versions that are specified in this go.sum. Right, so we don't have any other steps. We don't have any, ensure or install or anything like that. And that's really convenient because it's just one fewer thing we have to remember to do. Okay, so let's go to our Docker file now. This is how we build our image. Okay, and the image is going to be used directly on Azure Web Apps, Azure App Service, right? So it's going to be completely the same, and that's nice because we'll be able to test this locally. All right, so we've got kind of two major sections. The first section is here, the stuff I've highlighted. And the whole point of this is we're going to use this to build our app, and we're going to end up with a binary. It's going to be in /bin/agenda-API, excuse me. All right, so we're going to start with the Go 1.11 base Docker image. We're going to set up our Go path, but if you look at these lines here, we're not going to do anything in the Go path. So we are purposely setting up the Go path to be outside and completely separate from our app. Okay, that's important. Then we're going to copy all of our code in, and then this is sort of the magic piece. We're going to turn on the whole Go module system. Okay. So I'm going to skip over this. This is just turning off CGO to make things a little smaller. And then finally on line 8, this is where we set up the server that's going to serve all of our dependencies. So this is actually near and dear to my heart because this is an Athens server, and Athens is one of the proxies to serve Go dependencies. And so I love Athens. I actually started the project and I'm a core maintainer on it. And I'll put a link to it in the show notes. I could talk for hours and hours on it, but I'll spare you this time because we've got more to cover. So the final part in this build stage is to actually build the app. So Go build, like I was saying before, it's actually going to go and figure out what are all the dependencies, and it's going to actually go to this server and ask for all those dependencies. So once it's built, then it's going to output the binary to that place /bin/agenda-API. And that's going to be it for this first stage of the build. So if anyone's curious, this feature in Docker is called multi-stage builds. Okay. So now we're going to set up our second stage. That's everything from line 11 down. That's what I've got highlighted. Okay. So we're going to use the Alpine base image this time. And Alpine is just a super small kind of image that's really good for runtimes. And that's exactly what we've got here is a runtime. Okay. So we're going to copy in from the previous build stage, which we aliased up here on line 1. We called it builder. And we're going to copy bin agenda API from exactly where we outputted it in our Go build. And we're going to copy it into the exact same place in our new image. Okay. So our new image, everything from here down is going to be the only thing that is in our final outputted image. Okay. So all of this stuff, unless we copied it over like on line 13, it's going to all be gone in the final image. Okay. So we did copy just the binary. That's what we wanted. And down here, we're going to add some SSL root certs. Here, we're going to specify the port that we want the server to run on. Down here, we're going to specify that when the server runs in the image, in the container, that port is actually exposed. And then finally, we're going to say, when you do run this thing, run the app, right? So this is the default thing. Unless you override it, it's going to run the app. Okay? So for the last step of today, let's see this thing in action. Okay? So I've got a make file with two, let's actually check out the make file. It's got two targets, Docker build and Docker push. So Docker build will build up the image. Docker push will actually push it up to Docker Hub. That's the image registry we're going to use. And I'm going to do a Docker build, then I'm going to show running the image. That's going to run our actual server, and then I'll show Docker push. Okay. So let's do a Docker build. I'm going to clear the screen there. And we can see this is actually executing every single thing in that Docker file. All right, so let's go way back up to the top. Here's that from. We're setting up our Go path. We're setting up our apps path. And remember, that's outside of the Go path. We're bringing in all of our code, turning on Go modules, turning off CGO so that we don't have any of the bloat with CGO. We're pointing the Go module system to our Athens proxy. And then we're doing the build. All right, so when we do the build, all that red stuff below is the Go module system going and finding and downloading from that Athens server, and is downloading every single dependency we need, including the transitive stuff. Okay, so now that we're done, we've built the binary, we start our second stage of the build. So there you go, Alpine, it's bringing in the binary, installing the root certs, setting up the port, exposing it, and then finally running it. Okay, so if we scroll down, now we've got the image built. So now we can do a Docker run we're going to do --rm so that once we close down the server, the image will get erased. The container, which is the running image, will get erased. And then we'll copy and paste the image name in there. And there you go. So now the Echo server is running. We can't quite test it out yet because it runs on this random port. And we actually have to manually expose that port when we do the Docker run. So we'll test it out next time. But this is the basic idea. And this Docker thing is really nice because we can do a Docker run locally and test everything out locally. But when I upload it to Azure App Service for containers, it's literally going to do the exact same thing. So this command is super portable across everything from my laptop to whatever Azure's got going on, big data center that scales my thing and everything. So as long as I build the app, assuming that, it's not going to have shared memory, in-process memory, I'm good to go. I can test it out locally and I can, be confident that when it goes up to Azure, it's going to run the exact same. Okay. So let me close that down. Alrighty. So for next time, actually, let me show off the Docker push. So Docker push, as long as we already built the image there, you can see we obviously did, and then we ran it. Docker push is going to push that image. Okay, so if we go in, Docker push is basically going to be doing this, Docker push, and then the same exact image. So if I manually run that, you can see the exact same thing happens as make Docker push. So pretty straightforward, and that ends up on Docker Hub under Go Study Group / Agenda API. So if I refresh the page, there you go. I did the push a few seconds ago. And then a while back, I think earlier today, I did a push on an earlier build, which was even sparser actually than what I just pushed. Okay. So now that we've got our image pushed, we're going to be able to do iterations. So we can build code, we can add features, add tests, whatever, and we can keep doing the Docker push so that it's up on the public Docker Hub. And that's important that it's up on the public Docker Hub because then we're going to be able to pull it down and test it in CI. We're going to actually be able to push it up from CI, and we'll see how to do that later on. And then most importantly, Azure Web Apps is going to be able to pull it down to actually run my Docker containers to serve my API. Cool. All right, so that is it for today. In the show notes, you'll find a bunch of links. You'll find links to the Go Study Group. You'll find links to these instructions on how to run a Docker image in Azure Web Apps. I'll have links to the code base, obviously. I'll have links to Echo. I'll have links to a bunch of other stuff too. So look out for those. And this is going to be the start of a series, right? So we're going to take everything from what we've got now all the way through to getting our API deployed on Azure. And then after that, we're going to go into some crazy stuff, for me at least. And we're going to go to actually add that API to this page. And that's going to involve some front-end JavaScript and HTML, which I am terrible at. So cross your fingers that I'll be able to get that done too. And you'll see all of that live on these screencasts. So I hope you tune in next time, and I'll see you. See you later, Gophers.